Now for this part, let's move straight into primitive type variables. I've written a class called M1 here. So m1.java has only one main method. So let's trace through the main method. So when M1 starts, main starts. And we move on to line 3. Now, this diagram, now I'm going to go to put the output here. Output will be what you see on the DOS console, what is printed out to the DOS console. And on the left here will be my variables and the values. So on line 3, two things happen. A local variable called I is declared, and before that, let me write down the method name in which all these variables are declared. Okay, so I is declared and I stores a value 5. I is assigned the value 5. So this is how it looks like. On line 4, a new variable called j is declared and is assigned the value 10. On line 5, I'm going to print out the values of I and j. So the output will look like this. I is 5, comma j is 10. So far should be okay. We move on to line 7. Now line 7 actually assigns a new value to the variable I. So I now becomes 3, no more 5. Okay, the old value is thrown away. A variable can only store one value at any point in time. Alright, we move on to line 8. Now line 8 means assign the value in I to j. So the value in I happens to be 3. I'm actually storing 3 into j. So this is how it looks like after line 8. Now on line 9, I'm going to print out the values of I and j. Okay, 3 and 3. Now we move on to a silly loop here. It's silly because it's just an example. On line 11, you will check, is j smaller than 6? J is 3, right? So j is smaller than 6. It is true. I'll go into the while block. So on line 12, what happens? I'll be careful here. We're dealing with the post increment operator, which means the addition of j happens after the statement. So what I'm doing here is I'm setting I to j. So I equals to j, no change. All right, and then I increase the value of j by 1, j plus plus. So j becomes 4. I move on to line 13 and I print out the values of I and j. So I is 3, j is 4. Okay. Go back to line 11 to check the condition. J is still smaller than 6. J happens to be 4 now. So I go to line 12. I equals to j plus plus. So I equals to 4. Alright, the current value of j. And then j becomes j plus 1 because of the post increment operator. I go on to line 13 to print out the values of I and j. I get I is 4, j is 5. Okay, go back to line 11 and check this condition is still true because j is 5. And I'll do this one more time. I equals to 5 and j plus plus. And I go to line 13, print out the values of I and j. Okay, go back to line 11. This condition is no longer true because now j is 6. Hence, j is smaller than 6 is false. Because of that, I'm going to skip the whole while block and jump to line 11. Okay. Now on jump to line 16. Now line 16, I'm just trying to show you that another example of a primitive type, a Boolean type. Boolean b equals to true. The memory state diagram, it looks like that. Okay. On line 17, b equals to false. So this is what happens. On line 18, I'm trying to print out the value in b, which is false. False gets printed out. I'll move on to line 20, yet another example of a primitive type, the char. So line 20 declares a variable called c, and it stores the character e. This is how it looks like. Move on to line 21, a new variable called d, which stores the value of the character 9. Now 22, what is happening is I'm adding c to 1. So the value in c, which is the character e, plus 1 becomes the character f. And I'm casting it back to the character type and storing it in d. So d becomes f. Okay. On line 23, I'm going to print out the values of c and d. I'm going to get this c colon e, comma d colon f. That's it. Okay, I've gone through a simple example using, three primitive types: an int, a boolean, and a char. Okay, so memory state diagrams for primitive types are quite simple to draw. Now let's take a look at an example which involves method calling of primitive types. Let me start on a fresh sheet of paper. Now I have a class called M2. Now three methods in M2: the main method, the change val method, and the get value method. Okay, in the same way, I'm going to trace through the program and draw the memory state diagram. Okay, this program has got output, so I'm going to show the output here. So it will appear in your command window. Okay, the program starts, main starts. I go to line 3 and line 4. So this is what happens. Now before that, it might be a good idea to indicate that now we are in the main method. So I and j are both local variables in the main method. I move on to line 5. Now line 5 calls a method called changeVal, this one, and passes over the value in I. Remember, pass by value. What does that mean? It means the value in I is passed over. So the value in I is 0. A copy is made and passed over to line 12. So on line 12, there's another variable called x, and x is a local variable found in the changeVal method. So I'll put here changeVal, and x happens to be a local variable in changeVal. What will x store? X will store 0 because that is the value copied over from I. Now on line 13, I'm going to increase the value of x by 1. And on line 14, changeVal returns. It returns to line 6. Now, when changeVal returns, the local variables of changeVal will be thrown away, and there won't be any more x. So on line 6, I'm trying to print out the value of I in main, and that remains 0. Okay, the value of I is still 0. So this is the output 0. What I'm trying to show here, what I'm trying to demonstrate is that when you pass the value of I over to a method, there's no way the method can change the original value of I in the calling method. There's no way, because a copy of the value in I has been made and sent over. Okay, whatever you do with that copy will not affect the original value in I. Okay, bear that in mind. So in this case, changeVal, the method changeVal simply does nothing. Okay, it's a nonsensical method. Now, we move on to line 8. Now, line 8 calls another method called getValue and passes j over. Now, getValue is a bit different from changeVariable. Now, getValue returns an int. change variable returns a void. Now let's go on to get value. Now, get value has a local variable called x. So get value has a local variable called x, and what will x store? X will store the value in j. J's value is 0. So a copy of 0 is made and passed over to get value. So 0. Okay. Over here, I return 0 plus 1, which is 1. So 1, the value 1 is returned to line 8. What I've highlighted here in gray will be 1. What I'm doing here is I'm assigning j equals to 1. So j becomes 1. Okay, because of the assignment, j's value has changed, okay, to whatever get value returns. I go on to line 9 and I print out the value in j, and the output will be 1 because j now stores 1. Okay, I hope after this example you understand why it's the meaning of pass by value as far as primitive types are concerned. Okay. Now in the next part, we are going to move on to object reference types, a bit more complex.